Hello, everyone, and welcome to the Workplace Safety North webinar, New Diesel Exposure Limit for Underground Mines in Ontario. My name is Gabby Lemon, and I'm the event specialist here at Workplace Safety North. We appreciate your attendance here today, and we want to mention a few housekeeping items before we get started. Your microphones have been muted, and we ask that you use the Q&A at the bottom of your screen for speaker questions. Questions will be addressed at the end of the webinar. If you have any technical issues using the Zoom application, do let us know in the chat box and we'll do our best to help you. Please note, this webinar is being recorded. A link to the recording, a copy of the presentation, and resource information will be sent to you within a few days. Today, we are joined by Ina Commission and Scott Secord from the Ministry of Labour, Immigration, Training, and Skills Development, and James Johnstone from Workplace Safety North. I'll invite Ina and Scott on screen to start today's presentation. Welcome.
Morning, everybody.
Good morning. So good morning, everybody. My name is Scott Secord, as Gabby mentioned. I'm a provincial mining specialist with the Ministry of Labour, Immigration, Training, and Skills Development. And joining me today will be Ina Commission, who's a hygienist with the ministry as well. So we'll just begin with a quick disclaimer, and that the purpose of today's presentation is to assist workplace parties in understanding their obligations under the Occupational Health and Safety Act and its regulations. It is not intended to replace the Act or its regulations, and reference should always be made to the official versions of legislation. It is always the responsibility of workplace parties to ensure compliance with the legislation, and this presentation does not constitute legal advice in that regard. If you require assistance with respect to the interpretation of legislation and its potential application in specific circumstances, please contact your legal counsel. Ministry inspectors will apply and enforce the Occupational Safety Act and its regulations based on the facts as they may find them in the workplace, and this presentation does not affect their enforcement discretion in any way. So the amendments to Regulation 854 were announced on April 11th, 2023 by the Minister in an amendment package called Ontario Regulation 6923, which is posted on e-laws and has been incorporated into Regulation 854, also available on e-laws. This amendment package was developed in consultation with the Mining Legislative Review Committee over the last 3 or 4 years. And the Mining Legislative Review Committee is a Section 21 committee under the Occupational Health and Safety Act, which was formed of members of industry, labor, and the ministry to advise the minister on emerging health and safety issues in the mining sector, as well as provide recommendations on amendment proposals and changes. Within that minister's announcement, there was 2 in-force dates for this comprehensive amendment package. The July 1st date was mostly smaller housekeeping items, reference changes, and lesser updates, including things like ground control sections, the ladderways on surface, independently powered conveyances, vehicles on rails, modular training updates, and battery charging stations. More comprehensive changes to the Regulation 854 came into force on September 1st, 2023. Included management of change, supervisor duties, seismic risk management programs, explosive security and storage, airborne hazard management program, diesel powered equipment, airflow, and elemental carbon OELs, ventilation and heat and cold stress, and reagents and eye wash and antidotes. Today, we're going to take a little bit of a more focus on a couple of the key changes to Regulation 854. We're going to touch on the mining airborne hazard management program for mines and mining plants. And we're going to take a little bit of a deeper dive into the ventilation requirements for the use of diesel-powered equipment in underground mines. We're going to provide you some compliance considerations and some of the services that are available to help support compliance available through Workplace Safety North. So the key amendments that we're going to be taking a look at today are Section 182 for airborne hazard management programs, which apply to all mines and mining plants. We're going to be taking a look at Section 183, the general requirements for diesel-powered equipment used in underground mines. 183.1 for airflow rates where diesel-powered equipment is operated underground mines. 183.2 for the occupational exposure limits for elemental carbon from diesel emissions in underground mines. 183.3, which is the worker exposure for testing in underground mines. And sections 183.4 for tailpipe testing of diesel-powered equipment in underground mines. So first, we're going to take a look at the Airborne Hazard Management Program. And so the Airborne Hazard Management Program really is designed to help protect workers from exposures to airborne contaminants in hazardous mining environments. And this regulation requires that employers at mines and mining plants develop and maintain an airborne hazard management program. And this program is going to be similar to existing programs that you've seen before, which include traffic management programs and water management programs. And this program is really going to focus on recognizing, assessing, and controlling airborne hazards and their associated risks to prevent occupational disease in the workplace. The program needs to be developed in consultation with the Joint Health and Safety Committee, and it needs to set out measures to eliminate or control airborne hazards that were identified as part of the requirements for risk assessments under Section 5.1 of Regulation 854. And it needs to address specific items such as testing, monitoring, and sampling. And like the other programs, this program must be reviewed periodically, at least annually, to ensure its effectiveness, and workers need to be provided with appropriate information, instruction, and training in the program.
Hi, so as one of the occupational hygienists with the Ministry of Labor, Immigration, Training, and Skills Development, I often accompany mining inspectors when they do their physical inspections at mines. And when you see us at an inspection, to look at these new requirements, remember though that there already are existing requirements for industrial hygiene in mining workplace. So the Airborne Hazard Management Program really complements these other requirements. It's not really anything new, it just kind of ties everything together under one umbrella. So the hygienists help inspectors when it comes to enforcing the regulations I listed on this slide. For example, 833, control of exposure to biological or chemical agents, is the regulation that lays out exposure limits for many agents, up to about 700 air contaminants that could be present in workplaces. It does not include the limit for elemental carbon at this point, which is laid out in Regulation 854. But we look at these other regulations as well when it comes to air contaminants. And we also look at physical agents such as noise, which is included in its own regulation, and heat stress, which is included in 854. And there may at some point be a specific heat stress regulation coming. So the designated substance regulation, 49009, already requires mines, as well as other workplaces, to assess the potential for exposure and control that exposure when it comes to this specific designated substance, asbestos, lead, and silica, which are present at some mines. Thanks, Gabby. Next slide. So when we look during an inspection at how workplaces are complying with the Airborne Hazard Management Program requirements, there's nothing that we're looking for that's outside the realm of normal industrial hygiene or occupational hygiene at these workplaces. So we'll look to see that recognition of the hazards, it has been done. The workplace is aware of sources of air contaminants, the components of air contaminants, and the potential health effects. We'll look at assessment strategies. Has testing been done? Has air quality testing been done to see what the extent of worker exposure is? And is the workplace controlling exposure? When it comes to exposure, we expect workplaces to use the hierarchy of controls, which is shown on the slide. First of all, the most effective measure is elimination of the hazard. We can't, or we're not seeing elimination of all diesel equipment at this point, although for sure there's some elimination going as battery operated vehicles are being replaced. So that would be the most effective control measure, elimination substitution, but engineering controls is also way up there. So the main way that exposure to air contaminants produced in the workplace is done is through ventilation, and that's the primary engineering control. Administrative controls can also be effective, things like shifting shift times, control rotating staff, those kind of measures. And finally, as a last resort, there is the option to use personal protective equipment, but certainly we don't expect workers to be wearing respirators for a full shift in most situations. The other controls are much more effective. And WSN has a very useful infographic, thanks Gabby, which you can download for free. And the link to do so is at the end of the slide, our presentation, and it explains these approaches in a bit more detail than what I just did. Thanks.
Next, we're going to take a bit of a dive onto the general requirements for diesel-powered equipment, and this is outlined in Section 183. The first part of that is looking at record keeping. So diesel-powered equipment that's first used in an underground mine after June 1st, 1995 must meet the requirements established in the CSA standard M424.2-22, non-rail-bound diesel-powered machines for use in non-gassy underground mines. In the previous, prior to September 1st, mines were required to record information about diesel-powered equipment using the Notice of Diesel-Powered Equipment form that the ministry had provided. Under these new regulations, Section 183 requires that records be kept for diesel-powered equipment, and at minimum, those records need to contain the following information: the make, model, and serial number of the piece of diesel-powered equipment, the rated power, the RPM, and the maximum fuel ejection rate, the ventilation rates as certified in accordance with CSA M424.2, the make, model, and serial number of any emission control devices used with the equipment, and the capacity of both the fuel and hydraulic fluid tanks. Information also needs to be provided to operators of diesel-powered equipment. So employers at underground mines must keep and maintain information about the volume of air flowing in haulageways and workings where equipment is operating, and the total ventilation requirements for the equipment when it's operating in a single continuous course of air. And this information must be provided directly to operators or available in a readily accessible format. Additionally, under Section 183.14, it further requires that each piece of diesel-powered equipment must have the airflow posted in a location on the equipment that is visible and readable by the operator. And just a quick note that although it's not defined in the regulation, a single continuous course of air is generally considered to be a continuous path where the same air remains between entrance and exit, or a continuous path where the same air remains until a new source of air enters, or a path with a continuous source of air that has no addition from other sources. So essentially, the information that needs to be provided to operators of diesel-powered equipment is the amount of air flowing in their workings and haulageways, as well as the total ventilation requirements for the piece of equipment that they are operating. Section 183 also sets out the fuel requirement standards. And so diesel fuel used underground mines must meet one of the following Canadian general standards for diesel fuel: GCSB 3.517 for diesel fuel, or GCSB 3.520 for blended biodiesel fuels up to 5%, or 3.522 for blended diesel fuels up to 20%. Regardless of which fuel that standard is used, the fuel must have a minimum flash point of 52 degrees Celsius. So when thinking about what Section 183 and the compliance considerations, again, now that the notice of diesel-powered equipment form that the ministry has provided will still be available, that workplaces can use as a template for recording the information, although it's no longer required to be submitted to the ministry. And we're looking at providing information about the airflow in haulageways and workings where equipment is operating. Operators will be provided information at pre-shift lineup meetings or safety huddles through instructions from their supervisor, or pre-operational equipment inspection cards, or by digital means such as a phone or a tablet. And airflow rates that are required to be posted on equipment may include a placard mounted in the operator's cab or in a location visible from the operator's controls. So the crux of the big changes to in this amendment package regarding diesel equipment is the changes to the rules for ventilation, right? So where diesel-powered equipment is being operated in an underground mine, a mechanical ventilation system must produce the flow of air in accordance with the following rules. Prior to September 1st, there was only one rule for providing the airflow rates for diesel-powered equipment, and that was using a engine power times a factor, so the 0.06 meters cube of air per second for each kilowatt of engine power. And under the new September 1st requirements, there's 4 specific rules in which airflow rates can be determined. So the minimum airflow rate under Rule 1 is a piece of diesel-powered equipment that is certified with the CSA standard M424.22. And this can have an airflow rate equal to that rate posted on its certificate of homologation. And so the certificate of homologation is developed by CanMet Mining through comprehensive testing, and it tests for emissions such as carbon dioxide, carbon monoxide, nitrogen monoxide, nitrogen dioxide, and diesel particulate matter, and they produce a flow of air rate certification. And there's a list in this link that you can follow when you get the presentation to the CanMet list of certified engines and their airflow rates. So rule 2 is similar to the previous rule that you're familiar with, which is the engine power times the 0.06 meters cubed per second per kilowatt airflow rate. And this was known colloquially as the 100 CFM for brake horsepower rule. So equipment that does not have an M424 certified certificate of homologation certified airflow rate will need to use a minimum of 100 CFM per brake horsepower ventilation rate. So if we take a look at how this may apply in a real world scenario, here's a snippet of a certificate of homologation as provided by CanMet for a Caterpillar C13 R1700K Tier 4 final engine. So if we took a look at the rule 2, which is taking the engine horsepower or the kilowatts and multiplying it by the CFM rule, we could see that for a 345 horsepower engine, you would need to have 34,500 CFM of air. However, if you take a look at the the certified ventilation rate as required by Rule 1, it's actually only 12,500 CFM. So it's a big change there, and that's what the value of using the certified ventilation rate is. So if we take a look at Rule 1, and Rule 1 is using the certified ventilation rate, and Rule 2 was using the brake horsepower rate or the engine power rate. Rule 3 is actually determined for when you have equipment that is fitted with an after-treatment device, such as a diesel particulate filter, that doesn't have a certified or recertified airflow rate. And what Rule 3 does is allows the employer to determine the airflow rate in consultation with the Joint Health and Safety Committee. Must consider the pre-modification airflow rates, good engineering practices, and testing results. And this rule really accounts for changes that are caused by the after-treatment devices and maintains the effective ventilation with those added modifications. So when using Rule 3, there's a lot of things you need to think about to make sure that everything is done effectively and done well. So first and foremost, it's always about meaningful engagement and consultation with the Joint Health and Safety Committee. And this ensures that decisions are informed and they consider both technical and safety aspects. One thing that workplaces need to consider is the pre-modification airflow rate. So begin by considering the original airflow rate of the equipment before fitting the after-treatment device. And they need to evaluate how the addition of the after-treatment device will affect the overall emissions profile of that piece of equipment. When considering Rule 3, you also need to look at good engineering practices. So you need to employ recognized engineering practices to determine suitable airflow rate, using industry standards and guidelines, and ensure the modifications do not compromise the overall safety or emissions controls. You need to use testing results and emission data to utilize the emission test results obtained before and after installing the after-treatment device, and to make any adjustments needed for adequate ventilation. And you need to assess how the device alters the emissions, especially focused on contaminants that are under this regulation, such as carbon monoxide, nitrogen dioxide, and diesel particulate matter. Adding a DPF filter may increase the NO2, and those are things that need to be taken into consideration. One thing that needs to be done when looking at applying Rule 3 is historical certification rates. So look at any previous versions of engine certification under M424.2, and also compare historical emission data for that piece of equipment and based on the suitable airflow adjustments that have been done after these changes. And with anything, it's paramount that you have good record keeping. So we need to record all the calculations that are being done. You need to record the testing results, the consultations, and decisions regarding the suitable airflow rates. And you need to update the operator information and equipment placards with the new ventilation rate as they're determined. And these records need to be kept available at the mine site for reference and for regulatory compliance. The last rule for determining the minimum airflow ventilation rate when looking at diesel-powered equipment is to use the cumulative airflow rate, or Rule 4. And this is used when you have multiple pieces of diesel-powered equipment operating in this single continuous course of air. And what this means is that the total airflow rate needs to be equivalent to the cumulative ventilation rates, whether those are determined under ventilation rule rate 1, 2, or 3, and it needs to be cumulative for each piece of equipment that's operating in that heading. So this ensures that the overall ventilation meets the requirements when multiple pieces of equipment contribute to emissions, and it prevents a concentration of contaminants in a shared airflow path. So next we're going to take a quick look at a simple sort of example how this might look. So let's say you're in an active heading in a remuck, and you have a load haul dump machine loading 2 trucks. The load haul dump machine requires 35,000 CFM, and each truck requires 40,000 CFM. then total ventilation required would be 115,000 CFM. It's pretty simple, just adding up all the pieces of equipment together and making sure you have enough vent for all of them. So section 183.2 is really looking at exposure of workers to diesel exhaust, in particular diesel particulate matter. And so diesel particulate matter is emitted by diesel engines and is small particles of mostly respirable size, and those can reach the deepest part of the lungs. And these are composed of soot particles, polycyclic aromatic hydrocarbons, carbon, metallic abrasion particles, ash, and lesser sulfates and silicates. And one of the best things that we do to assess worker exposure to DPM is to measure the amount of elemental carbon that's available in the ambient atmosphere. And the reason why we use elemental carbon as the surrogate for measuring all the DPM levels is because it can be accurately measured at low concentrations, and diesel engines are likely the only source of the elemental carbon in the underground mines. So under section 183.2, the time-weighted average exposure for worker to elemental carbon shall not be more than 0.12 milligrams per meter cubed of air. So prior to September 1st, the TWA, time-weighted average, was 0.4 milligrams of total carbon, or elemental carbon times 1.3, and total carbon was equivalent, is comprised of elemental carbon elements as well as the organic carbon component. And so a time-weighted average airborne concentration of a biological chemical agent is always measured against an 8-hour workday or a 40-hour work week. So under section 183.3, employers at underground mines must conduct testing of the volume of airflow in underground haulageways and workings where diesel powered equipment is operating at least weekly. And a worker may request that employers test the personal exposure to carbon monoxide, nitrogen dioxide, or elemental carbon. And the results of the test must be recorded and maintained, readily available, and shared with the Joint Health and Safety Committee.
When the Ministry of Labor, Immigration, Training and Skills Development hygienists are present on the site, we like to look to see that the sampling is being done correctly and any calculations that are done are in compliance with the requirements of Regulation 833 and also the mining regulation. So we expect to see that a workplace is following sound industrial hygiene practices. The best way to do this is ensure that the sampling is designed, developed, and completed under the direction of someone like a certified industrial hygienist or a registered occupational hygienist. But really, it has to be a person who has the knowledge, experience, and training in the practice of industrial hygiene. So, for example, with respect to sampling strategy, who's getting sampled, when are the samples getting collected? Are we sure that we have a good representative sampling of different conditions, including worst case exposures and including routine exposures? When it comes to analysis, which laboratory is doing the analysis? Are you using a laboratory that follows some kind of proficiency in analytical testing program, or is certified by one of the agencies, that runs these programs? How is the sampling being completed? The method is laid out very clearly in the reference given below, the NIOSH 5040 method for sampling and analysis of elemental carbon. Who taught the person how to do the sampling? We're not expecting people to be accredited hygienists if they're doing the sampling, but for sure we expect people to be trained in the right procedures. How does the sampling equipment look? Is it well maintained in accordance with the manufacturer's instructions? Is it calibrated? Does the calibrating equipment work? Is it being calibrated routinely, once a year or whatever the manufacturer recommends? What kind of procedures are in place to assure quality? Or is everything documented? Are records being kept? Is a chain of custody form submitted with the samples when they go to the laboratory for analysis? And finally, we'll look at data assessment, like where's the data maintained? How is it assessed? Who's interpreting what the air sampling results mean? Are there trends being tracked so that we can see over time Is it always the same result we're getting? Are there anomalous results? Is there a certain area where the results are higher? Has this been looked at to see if it's maybe a particular machine or a set of equipment? Subsection 6.1 of Regulation 833 requires that any sampling be done, following a standard method and by a person with knowledge, training, and experience in the practice of industrial hygiene or occupational hygiene. The second bullet shows you the standard method, and there's a link there. NIOSH is the National Institute for Occupational Safety and Health in the United States. They're an agency that has been developing and publishing standard methods for workplace air sampling for many, many years. The methods are constantly reviewed and updated, and they've been validated. There is no direct reading instrument for elemental carbon. There are direct reading instruments that measure size fractions of airborne particulate matter. These can be very useful, for example, to identify sources of elemental carbon, airborne elemental carbon, and they can also be very useful to track trends and evaluate the effectiveness of control measures like ventilation, but they do not read directly out the concentration of elemental carbon. When direct reading instruments are used, and these are available, and you commonly see them underground as multi-gas meters that include sensors for oxygen, maybe volatile organic compounds, carbon monoxide, nitrogen dioxide, and other gases as necessary. There's a requirement now in Regulation 833 under subsection 6.2 that these devices be maintained and calibrated in accordance with the manufacturer's instructions. So we like to look at calibration records. How are you documenting that the device was calibrated? We look at calibration gas, make sure it's not expired. We look at docking stations to see that they're programmed correctly with the right concentration of calibration gas. And those are just a few of the things we look at when we're on site. Okay, next slide.
Thanks, Hannah. So if worker exposure tests indicate that a worker has been exposed to carbon monoxide or nitrogen dioxide in excess of the limits set out in Section 4 of Regulation 833 for the control of exposure of biological to chemical agents, or elemental carbons in excess of the limits set out in Section 183.2 of 0.12 milligrams per meter cubed, subsection 183.34 requires that employers investigate the cause and take remedial action, and if possible, needs to prevent reoccurrence. Employers are required to notify affected workers and the Joint Health and Safety Committee of the exceedance and retest and confirm that the concentrations do not exceed the applicable limits.
Okay, so not to scare anybody off with an equal sign here, but Scott already started that ball rolling. I thought I would include an example of a calculation for a time-weighted average daily exposure. The calculation formula is given in Regulation 833 in one of the schedules. So the example here is considering a worker who's exposed to elemental carbon. A sample's been collected over a shift lasting 10 hours underground, and the rest of the shift was in the dry, above ground, at team meetings, in places where we do not expect any elemental carbon or diesel exhaust to be present. So it's reasonable to assume that the rest of the shift there was zero exposure. So the calculation of daily time-weighted average, the general formula is given in the top equation. It's the cumulative exposure, which is the concentration that is measured, times the duration of time that worker is taken to be exposed to that concentration. So C1, T1 means for measurement number 1, what's the result? How long do we think the worker was exposed to that concentration? And then you do that for every exposure. So in my example, and then you take the cumulative exposure and you divide that by 8. No matter how long the exposure time was, you still divide the cumulative exposure by 8. What this does is normalize the exposure to an 8-hour shift. It expresses it in a way as if the worker got that exposure during an 8-hour shift. And that's the value that we compare to the time-weighted average exposure limits in the regulation. So for my example, we take 10 hours of exposure times a result of 0.09 milligrams per cubic meter of air, and we add that to 2 hours of exposure times 0 milligrams per cubic meter of air, and divide that by math, that sum, and the result is a daily time-weighted average exposure of 0.11 milligrams per cubic meter of air. The calculated time-weighted average exposure is below the limit of 0.12 milligrams per cubic meter. So the result that you see on the laboratory certificate, I'm not sure if you can see my cursor, but maybe, Gabby, I'm trying to point at the 0.09 up here. The result that we got is not the result that we compare directly to the limit. We have to do the math, calculated daily time-weighted average. The result of 0.11 milligrams per cubic meter is what we compare to the limit. And zingo bingo, it's less than the limit, so there's no overexposure in this case. And a similar calculation is done for a weekly time-weighted average exposure. The result of a weekly exposure is still compared to our limit of 0.12, even though it's expressed as a daily limit. Okay, next slide. I think I'll talk to this one too. So what else do we do when we're on site? We might verify that that the correct occupational exposure limits are referred to and the correct calculations are done. What I see is many folks using Google, Googling the term occupational exposure limit. They might find some OSHA limits, which are American limits. They might find some limits from other provinces. We want to make sure that folks are comparing their results to our Ontario occupational exposure limits in Regulation 833. So those come from Table 1, which is in the regulation, but also we reference, at this time, we're referencing the 2017 version of the ACGIH exposure limits. That's the American Conference of Governmental Industrial Hygienists from 2017. To make things simple, we have posted on our website at this link all of the limits that are relevant in Ontario. And as I mentioned quickly, the diesel particulate exposure limit isn't in there. It's in Regulation 854. So for example, the time-weighted average limit for carbon monoxide is 25 parts per million, and the time-weighted average exposure limit for nitrogen dioxide is 3 parts per million. Now, for some agents, we also have short-term limits. For example, for nitrogen dioxide, there's a short-term limit. If you're exposed to a concentration over a period of 15 minutes or less, then the higher short-term limit is, I think it's 5 parts per million. For carbon monoxide, there are no specific short-term limits laid out, but we do have excursion limits. So recognizing that sometimes there may be exposures that go higher than 25, as long as they don't last too long, that might be all right, as long as the time-weighted average concentration calculated the way I showed you still is under 25. If you have questions about that, you can submit those to our contact center and somebody will get back to you and explain that to you. For some agents, rather than adjusting a worker's, or rather than calculating a time-weighted average exposure limit as it would be over an 8-hour day or a 40-hour work week, it is possible to adjust the exposure limit. So instead of calculating exposure, you look at your sampling results just the way you got them over the 10-hour shift or 11-hour shift or 12.5-hour shift, whatever it is, and look at an adjusted exposure limit. So the only method that we accept for that right now under 833, this is in the regulation, is the IRSST model. So this is an agency of research and evaluation of exposures in the province of Quebec. And it's called for short the Quebec model. I put a link in there for you as well. Very useful tool for adjusting exposure limits, but you really have to be careful when you use it. There is not an adjustment factor for every single air contaminant. So that's one of the limitations. Be careful to look at the English version of the model. If you're not fluent in French, make sure you're looking at the correct air contaminant. Also, be super careful because some of the Quebec occupational exposure limits are different than the Ontario limits. The model produces the result for the Quebec exposure limit. And if you're using another limit, like the one in Ontario, you have to do some math to get the new corrected occupational exposure limit. And these limits are never intended for use on short-term or ceiling exposure limits. They're only meant for time-weighted average exposure limits. There is no Quebec model adjustment for elemental carbon. The whole basis of the Quebec model is using the toxicokinetic information available for an agent. What's the fate of that agent in your body? Which organs are involved in detoxifying it? Where does it end up in your body? And what are the health effects? How long does it take to clear out of your system? So there isn't that information available for elemental carbon at this time. So there's no Quebec model adjustment for elemental carbon, and there isn't one for many agents. So many workplaces have used previously an older model that was not based on the toxicokinetic information that's now available. And one of these models is called the Brief and Scala model. It's a simple model that uses hours of exposure over 8 for the adjustment. We don't accept that. So if that's what your workplace is using, that'll need to be updated. Okay, Gabby, okay, get ready for this one. So I did an example for you showing the use of the Quebec model. And what I did was consider the case of a 12-hour workday, and that would give you an 84-hour work week if you work 7 days a week. Many mining workplaces use a 2-in, 2-out rotation. So I use that one. And if you look at a full month of 4 weeks, that gives you an average of 42 working hours per week. And let's look at the case of carbon monoxide exposure. So if on a given day, a worker is exposed to 25 parts per million carbon monoxide, that's not over the exposure limit. It's exactly at the value of our exposure limit in Ontario. And they were exposed to that 25 parts per million, not for 8 hours, but for a 12-hour shift, then we would calculate the worker's daily time-weighted average by multiplying 12 hours times 25 parts per million and divide that by 8. So normalized to an 8-hour day, that gives us a time-weighted average exposure of 37.5 parts per million. This is an overexposure. Clearly, 37.5 parts per million is higher than 25 parts per million, so the worker's overexposed. If we look at the other way of doing things, looking at the Quebec model and adjusting the exposure limit itself, it won't be 25 anymore. It'll be adjusted by multiplying by the factor provided by the Quebec model, which in this case is 0.67. And that gives us a result or an adjusted occupational exposure limit of 17 parts per million. So the worker's exposure of 25 parts per million over the 12-hour shift is higher than the 17 parts per million adjusted exposure limit for a 12-hour shift, and the worker's overexposed. So I hope you can see that these two methods give you the exact same result. The worker's overexposed. And it doesn't, I like to look at calculation of 8-hour daily time weighted average, but it won't matter if you use an adjustment factor for the Quebec model. You'll still see that the worker's overexposed. And the key is we need to take some kind of action to protect the worker. What else do we look at? Well, we'll also look at other aspects of the occupational hygiene sampling and control program. So we'll look at sampling equipment. We'll make sure you're using it correctly. We'll make sure that the size separating device. So this worker is wearing an air sampling pump connected to a filter. Prior to the filter, there's a size selector that's a 10 millimeter nylon cyclone. It's right side up. It's the right cyclone to collect the respirable fraction, and it's going to be clean, it's going to be well maintained, and the pump is going to be calibrated. So we'll usually, or we may ask the person doing the sampling, well, show us how you set this up. Show us your filters. Which filters are you buying? Where do you get them from? You know, do you have a calibrator? Are you renting equipment? Who do you rent it from? So those kind of technical aspects of sampling are something we'll dig into while we're on site. We also like to review the records. Have you used exposure groups to classify exposures? How do the results look? Are any of them over the limit? Are they consistently under the limits? I'll compare laboratory certificates, you know, to a specific set of sampling results. I'm not going to proofread your whole sampling program, but I'll do spot checks to maybe see if there, you know, if there were transcription errors. Overexposures, if there have been any overexposures, how do you communicate this to the workforce? How do you investigate? Is the Joint Health and Safety Committee involved? And how are the overexposures addressed? What's the plan? What's the action plan for dealing with these overexposures? At the same time, remember, we're also going to be looking at other aspects of your hygiene program. We'll look at noise measurements, maybe heat stress assessment. If respiratory protection is used to control exposures as a last resort or under particular workplace conditions, remember that Regulation 833 and 490 both apply or may apply in a certain situation, and they both require a written respiratory protection program with elements as laid out in the regulation. So we'll double check that as well. Okay, Gabby.
Thank you. So far we've talked about the ventilation rates as they relate to diesel-powered equipment. And so if we use Rule 1, 2, or 3, or even 4, what we're establishing is the minimum ventilation rate that may be required where diesel-powered equipment is operating. But as Ina mentioned, Regulation 833 for the control of exposure to biological or chemical agents requires that employers take all measures reasonably necessary in the circumstances to protect workers from exposure to hazardous biological or chemical agent because of the storage, handling, processing, or use of such agent in the workplace. And so in your mind, there may be situations where airflow rates based solely on the diesel-powered equipment may not be sufficient for managing other airborne hazards. And that could be such as silica, blasting contaminants, or even heat. And so, you know, if you have electric equipment operating or battery-powered equipment operating, the minimum ventilation rate won't be set by diesel-powered equipment, but it'll be set by your airborne hazard management program to make sure that workers have the appropriate quality of air. And again, we're really focusing on that air quality versus air quantity. So prior to September 1st, a lot of the diesel rates were based on that air quality or air quantity calculation. And now we're really focusing on making sure that workers have clean quality air. And so the air quantity needs to be able to supply the quality of air that's required. Section 183.4 really looks at tailpipe testing of undiluted exhaust. And so tailpipe testing is critical to make sure that engines and after treatment devices are operating as they're supposed to. And employers must develop safe measures and procedures for testing exhaust, undiluted exhaust from the tailpipes, and that procedures and processes must be developed in consultation with the Joint Health and Safety Committee. Each piece of diesel-powered equipment must be tested under consistent conditions and, as far as practical, under full load. Exhaust testing must be performed routinely, at minimum once per month, or more frequently as required by the manufacturer, or if any repairs are done to the engine or exhaust systems. And employers are testing to make sure that undiluted exhaust from diesel-powered equipment contains less than 600 parts per million by volume of CO and less than 60 parts per million by volume of NO2. And this 60 parts per million by volume NO2 is new under this new September 1st regulation amendment.
Mhm.
So when doing undiluted exhaust testing, all testing equipment should be used following manufacturer's recommendations. And you want to use equipment that prevents condensation in the sampling line when testing for NO2, as water can severely affect the sensor readings for that element. And as mentioned before, you want to ensure tailpipe testing is consistently done. So it needs to be done at normal operating temperatures after CO and CO2 levels have stabilized, and again, is under full load as far as practical. When engines fail to meet the prescribed limits, they should be removed from service and inspected to determine the cause of the failure, repaired, and retested to ensure compliance. And the results of all this testing must be recorded and kept readily available at the mine site.
And Scott, we don't approve or accredit or recommend or require any particular testing device for tailpipe testing, but I threw a couple of common commercially available examples up there. Remember that these devices are also direct reading instruments for measuring airborne contaminants, and so they fall under the requirement of 833 subsection 6.2 for calibration and care and maintenance and use according to the manufacturer's instructions. So we may also request others have a look at the test records and see what's going on.
So I guess the big summary from all of this is that, these are some pretty substantial changes, but they're kind of in line with the things that we're already doing, right? So we're always measuring the airflow rates. We're always measuring for exposure to DPM in the workplace. We've just lowered the limits a little bit, but we've given flexibility to employers and workplaces to have flexible ventilation rates that are really, again, aimed at looking at the air quality aspects. But all of this can only be done with meaningful consultation with the Joint Health and Safety Committee. And that's really essential. This collaborative approach really makes sure that decision-making ensures worker safety. And, meaningful consultation goes well beyond just information sharing, but involves incorporating recommendations and actions. So get out there, work with your committees, take a look at these new amendments, and spend some time with your maintenance teams and your ventilation teams and take a look at the options that are in front of you now, because there's really some pretty exciting stuff that's happening with ventilation in underground mines.
Sorry.
All right, thanks for the opportunity to let everyone know. WSN's accredited IH team can certainly help firms meet these new requirements we've been learning about today. So WSN's industrial hygienists use accredited industry best practices in sampling equipment. We follow standardized sampling methods and work with certified labs who also provide the calibrated sampling equipment and sample analysis. And our specialists, incidentally, are Canadian registered safety professionals who really have a deep understanding of how a company's health and safety management system could incorporate what we've been learning about today. So if you're unsure, we're here to help and guide firms, into compliance and hopefully beyond. We can also educate and mentor on-site personnel, and of course the Joint Health and Safety Committee in industrial hygiene best practices in regards to what we've been learning about today. On the next slide, I have a few resources that we've included, and again, I believe this PowerPoint presentation is going to be sent out to all of our participants, so you'll have access to this after. If you went to our website and you searched keyword diesel, you're going to come up with similar results as this. We have quite a few resources for firms up on our website, which are hopefully quite helpful. So you can see a few here: reducing diesel particulate matter in underground mines. We had a couple of successful examples to speak about there. The health effects of diesel exhaust in mines, And we even have some information from ResearchGate and the Occupational Cancer Research Center regarding, again, diesel particulate matter in underground mines.
Oops.
All right, so if there's any questions for additional information, please contact WSN's IH team for any further information on that. Thank you, Gabby.
Wonderful. Thank you to James, Scott, and Ina for joining us this morning. We now have some time to take audience questions, and there are quite a few. So I think I'll just start from the top of the list, which is, so we have a question here. What training will be done for inspectors in the province to ensure they understand the requirements and technical information well and consistently apply and enforce these new regulations?
Yeah, I guess I'll start with that one. Like with any of our regulatory requirements, our inspectors receive comprehensive and thorough training on their enforcement, their application, and so on and so forth. And anytime we have amendments to that regulation, there is additional comprehensive training that inspectors will apply. If you have questions about enforcement or compliance as it relates to specific circumstances, I always recommend dealing with your local inspector directly.
And
And
I was going to add, Scott, that all of the inspectors have access to our specialized professional services specialists in industrial hygiene, occupational hygiene, like myself, but we also have mining engineering, ergonomists, like whatever specialist the inspector needs to help them out, they're also available to, in addition to any training that they receive.
Yeah, like, you'll definitely probably see Ina out and about in mines and stuff like that, joining the inspectors. And I think she's clearly demonstrated her knowledge and skills and comprehensive qualifications when it comes to understanding and applying these regulatory amendments.
Perfect. Thank you both. Next question. With respect to the hierarchy of controls, if mine workers are being told they must wear respirators for their full shift, is there a reporting mechanism in place for workers to flag this for the ministry, particularly concerning the non-unionized mines?
Yeah, for sure. We have a call center where any worker or any person can call anytime if they have a concern about workplace conditions. So I think I can post that phone number in the chat, but it's also available through email.
And additionally, on your Joint Health and Safety Board, there's a requirement to post the contact information for your local inspector. And so you can go by there and take a look and contact your local inspector directly to identify any concerns that you may have.
Mm-hmm. And, we really expect workplaces to rely on the internal responsibility system. So, the first call isn't to us. The first call is through your, the first concern is expressed to your supervisor. And if that doesn't work, then the Health and Safety Committee is there to make sure that those concerns get out in the open and stay in the open until they're addressed.
Thank you. Next question is, if a DPF filter is used, are we able to still use Rule 2? If testing shows no dangerous increases to NO2 until the updated CFM decrease is brought to the Joint Health and Safety Committee?
Yeah, so I think what you need to look at is when you're losing Rule 1 or Rule 2, that establishes the minimum ventilation rate. And Rule 2 is obviously based on the engine horsepower, and as seen by that example we provided, is generally much higher than the certificate of homologation. And so I think this question relates to sort of the application of Rule 3, which is, you've applied a DPF filter, you're busy calculating your new ventilation rates that's on an uncertified filter, and until the time is that you're confident that those rates that you may switch to are available, then yeah, you can continue to use Rule 2, because remember, Rule 2 sets the basement level, so that will be higher ideally than when you've applied the after treatment device. And so you can use that Rule 2 for uncertified ventilation rates until the time as you develop them using Rule 3.
Great, thank you. The next question is, does the new standard include clarification with regard to ventilation requirements when the prime mover does not have a CAN-MET ventilation certification, but is also not a diesel engine? For example, an electric drive, which in the prior standard used to have ventilation prescription based on BHP, even though it produce no emissions?
So even prior to September 1st, those ventilation rates as outlined were really prescribed for diesel powered equipment. And so if you don't have diesel powered equipment, then those minimum ventilation rates for diesel powered equipment wouldn't apply. However, as mentioned, there are many other contaminants in the workplace that need to be addressed, and often that's addressed through the engineering control of ventilation. And so those considerations would probably become the primary consideration when determining your ventilation rates.
Thank you, Scott. The next person submitted a two-parter. So their first question is, they're wondering if heat exposure has been considered with the ventilation changes.
So there is a requirement for heat management of procedures, or thermal stress procedures, heat and cold management. Like I mentioned in the presentation, that the diesel ventilation rates again represent the minimum ventilation rate, and other factors need to be considered through the airborne hazard management program in determining your ventilation rates. So if excess heat is one of those considerations that at your workplace, and you use ventilation as a way of managing that hazard, then that would need to be considered in addition to the ventilation rates for the diesel powered equipment.
And I just might mention, Scott, that we accept the use of the ACGIH screening values for heat stress. These are screening values that require measurement of wet bulb globe temperature as the environmental measurement. So it's not sufficient to just measure temperature to assess a person's risk of heat stress. There are other factors such as radiant heat, humidity, and you have to consider metabolic workload as well. So how hard is the person working? So when a workplace is evaluating heat stress, that's really what we turn to is the WBGT guidelines for published by the ACGIH. And there are other methods out there. There are new methods, but heat stress is another topic maybe for another day. So I'll stop there.
Thank you. And their second question is, are you aware of any other sites implementing visual aids such as stickers on equipment or placards for airflow updates, and what might that look like?
Mm-hmm.
I'm not individually aware of those, but the placards need to be updated with the airflow rates as required by the piece of equipment. And so, yeah, or the haulage ways that they're operating in. So, I mean, I know you might have seen more specific examples than I have on this.
I like to see, there's no, we don't regulate or prescribe the format, the color, the size, anything like that. I have seen stickers used and placards used for many, many specific warnings. We don't prescribe the format, but we want them to be clear, legible, visible, and we want workers to understand whatever system is being used.
Excellent, thanks. The next question is, what evidence are you requiring to identify the worker is, for example, only underground for 10 hours in a 12-hour shift? And then in brackets, TWA calculations.
Yeah. So remember that my example was just that, an example. I'm not saying that every worker is underground 10 hours out of 12. And we look at the conditions at the workplace as we find them when we get there. So the best person to ask is the worker themselves. They certainly would know where they were during the shift. And, we talk to foremen, we look at notes, we go underground ourselves and we see what's going on. And in the worst case, if I thought that a worker was underground longer, then I would use a larger number to do the calculation. And I was going to say, I forgot to mention some of the devices that the direct reading instruments for carbon monoxide, nitrogen dioxide, they also are data loggers, and they're doing the same calculation that I did. They always assume an 8-hour shift unless you program them differently. So we can look also at the programming of those direct reading instruments and see how well it matches to the conditions in the workplace.
Thank you. The next question is, none of the 4 rules specify battery electric. Can you comment on how to determine airflow needed for this type of equipment?
Yeah, so again, the 4 rules specifically relate to the minimum ventilation requirements where diesel-powered equipment is operating. So for battery electric vehicles or electric vehicles of other types, or they would need to determine the ventilation rates as required to maintain the air quality aspects as set out under 833 or heat management, et cetera. So again, 183.1 rules 1 through 4 are specifically targeted at identifying the minimum ventilation rates where diesel-powered equipment is operating.
Great.
Mhm.
The next question is, they are wondering if you can comment on a rule of thumb for OHs of 50% action level best practices based on OEL, where controls are not recommended as the OEL does not provide for overexposure, but it is not a fine line between toxicity or not.
Absolutely correct. And we enforce the occupational exposure limits, and how a workplace decides to protect their workers is up to them. The use of the action value or action limit, 50%, 60%, whatever a workplace would like to use. Even the question tells me that that person has some very good background information in the practice of occupational hygiene. So it's a best practice that can be used to help workplaces identify when workers may be at risk, and they can institute controls earlier than the exposure limit. Of course, we love to see that. We really want to see, and it's really laid out in Regulation 833, that we want workers to be exposed to no air contaminants. So ideally, the exposure should be as low as reasonably achievable, and the occupational limits are sort of a fine line where we enforce. But we don't enforce action limits. Action limits are a really good best practice for occupational hygiene programs, and for air hazard management programs, that can be, part of the management program that's written in. That this workplace is going to follow an action value of 50%, and at 50%, we're going to do action A, B, C, D, E, whatever it is to control exposure. Not something we enforce, though.
Another question, with respect to calculating DPM exposure, why is the Quebec model not adequate?
It's not that it's not adequate. The Quebec model does not provide a correction factor for elemental carbon. As I said, the Quebec model provides adjustment factors for many agents, but not all agents. It doesn't have a correction factor for nitrogen dioxide either. It all depends on, as I understand it, on the toxicokinetic data that's available for a particular agent. And then the IRSST developed adjustment factors for agents when they had sufficient information.
Great. We have a question here asking, for purposes of the new regs, should a baseline be done prior to increasing the number of equipment, or can it be based off of pre-existing data?
Yeah, I love the idea of collecting baseline data, but that'll be decided internally, I think, at each workplace.
There's another question that's very similar. I think someone's saying, so the minimum ventilation requirements are a baseline and may need to increase to account for the other contaminants and exposure limits. Is that correct?
Yeah. Like right now, the easiest thing, I think, we're not going to tell a workplace how to manage their airborne hazards, but it seems to me that collecting baseline data under current ventilation conditions is a really good place to start, and then see if you need more or less air from there.
Perfect. A few more questions. So any comments on section 286 relating to air recirculation, which has been revoked?
Yeah, so a lot of those sort of smaller regulatory requirements were sort of rolled into a new updated to section 252, which includes a more holistic way of looking at air in workplaces that includes underground and mines and mining plants. And so there's I believe it's 252 sub 3 deals with recirculation of air. And so it's been basically moved from 286 over to 252.
Another question here asking, can you use stationary gas monitors in place of weekly testing, or do they need to be on individuals, i.e. gas badges?
So again, a really good and complex question. You know, this is an example of why an airborne hazard management program really probably needs some input from an occupational hygienist who's familiar with the practice. So many studies suggest that the results would be different. If I'm a worker and I sit on the same machine all day, if a hygienist collects a sample in my breathing zone, it may very well be different from the result if the sampling equipment is just left on the machine. And the differences can be small or the differences can be large, you know, like I'll give you the example of welding. A welder wearing an personal air sampler may have a result that's 10 times different than the result from an air sampler sitting on a bench. So we do not specify personal breathing zone sampling, but we will look at the sampling strategy and the methodology, and will determine that the sample has been collected appropriately to measure a worker's exposure. So the short answer is sometimes stationary air samples are okay and they're representative of results, and sometimes they're not. And if we're not comfortable with whether a sample is representative, we may require the workplace to repeat the sampling or do side-by-side sampling or take some other action that supports the validity of the sampling data that they have.
Thank you. And the last question we have here is asking, is there a standard for using biofuel higher than B20 underground? And they reference section 183.
So right now, the Canadian General Standards Board, the GCSBs, has outlined these 3 specific standards, and they maximize at about a 20% biofuel. And I believe that's the maximum standard that exists with at the federal level. And so I do not believe that there is a higher than B20 national fuel standard. One thing to consider too when taking a look at using biofuels underground is they can affect your emissions profile. And so when selecting fuels, it's important to sort of test and analyze your exhaust to make sure that the fuels that you're selecting, high quality fuels that, depending on the blends that they have, are producing emissions that you understand.
Great, thanks, Scott. So that's all the questions we received today. So I want to thank everyone who submitted a question and to our speakers for your thoughtful answers. Before we close out the webinar, I do want to ask any of the speakers if they have any final thoughts that you want to leave the audience with.
Yeah, I just want to really thank WSN for the opportunity. I know that many of the workplaces I've visited have many questions about the new requirements, and we hope that the webinar helped. And we're available if you have further questions, and when we're on site, feel free, we can discuss it further.
Wonderful, thanks, Ina.
Yeah, thanks. Just one thing I'd always remember to remind everyone is that if you have questions about compliance or about the regulations, always reach out to your individual local inspector. They're your partners in this journey together, and so everyone here at the ministry is excited to do that with you guys. So,
yeah,
thanks, Scott.